Okay,
Yeah.
so why don't we look at why, on a physical, simple, basic, common sense understanding of why a surgical mask may not work in this context because of all the gaps and put it on, take it off, and then we can address the N95 mask and the cloth mask later. But the surgical mask is pretty much, I think, the standard for most people if they're going to use it. I mean, there's people on other ends too, but let's hit that one first.
Well, first, I think it's important to say and to recognize that when we try to explain why and elucidate why using physics and chemistry and biology and how you get infected and what is the minimal infectious dose and all these things, as soon as you start to get into the mechanism, you're just making up a story in a sense. Like you're trying to use scientific concepts.
Well, sometimes story sells sometimes.
Yes, but I just want to emphasize that this is not, whatever mechanism we describe and come to believe might be the most plausible one, is not one that has been demonstrated to be true by randomized controlled trials or anything like that, okay? So you have to separate that the randomized controlled trials tell us, first of all, that masks don't work in this application, okay? And if they did work, you would have seen it, and you're trying to detect it, and you don't detect it. That's one thing. And that is separate from trying to have a story of, well, why is it? Because people confuse these two categories of explanations. And I think it's important to recognize that no matter how clever your explanation is, it may not be right, okay? So that's the first thing. Now, in terms, I've gone ahead and tried to develop the best possible explanation as to why masks don't work. And as I said, I've come to the conclusion that the most prominent vector of transmission is these fine aerosol particles. And those fine aerosol particles will follow the fluid air. So in a surgical mask, there is no way you're blocking the fluid air. When you breathe wearing a surgical mask, the lowest impedance of airflow is through the sides and tops and bottoms of the mask. In other words, very little of the airflow is going to be through the actual mask. The mask is only designed and intended to stop your spitballs from coming out and hitting someone. It's not about ensuring that the flow of air is through the mask, and it's not through the mask, it's through the sides. And if the flow of air is through the sides, whatever is carried in the air, whatever molecules or small particles are carried in the air are going to flow that way as well. And that's how you get infected. Now, that means that if we're correct in this picture, which I believe is correct, that for now it's my most plausible working model. If that is true, those aerosol particles are going to go out as easily as they're going to come in. In other words, any aerosol-like particles coming out will go out in the same way. There's perfect symmetry here in terms of the physics, okay? So it's just, if you're not stopping them coming in, you're not stopping them coming out either. They follow the flow, period. That's the way it is. So that's why there's an equivalence, I think, between it doesn't protect you and it doesn't protect anyone else either.
Now, one of the arguments that the mask proponents state is that although what you said is true, they believe that it reduces the total viral load, that the obstruction to breathing out is going to catch some of these spitballs, and as a result, you won't have as large a viral load being emitted by a potentially infected individual. And that is their justification why wearing the mask doesn't protect you, it's protecting them.
Yes, I know that, but it's not relevant. The large droplets drop to the floor immediately. They're not breathed in. Okay? So they're not part of the transmission mechanism. I mean, let's put it this way.
Yeah, everything. This is what they're saying, though. This is what they.
I know.
This is conscious. This is why it has to be addressed.
I know. Everything is possible. Very few things are likely. Okay, so you can do a scientific study that demonstrates that viruses survive a fairly long time on a surface, whatever that surface is, and you can study different surfaces. That does not mean, these are called fomites, these surfaces where viruses can live or stay alive and stay active. That does not mean that transmission occurs through surfaces. It only means that a scientist was able to establish that a virus can survive a long time on a surface. It doesn't tell you anything about the the likely transmission mechanism of the disease. And so there are a lot of studies like this that are just basically irrelevant in terms of transmission mechanism. For example, there's a whole bunch of studies that physically demonstrate that a mask or a cloth or anything will stop some droplets when you try to push droplets through it. It's irrelevant because that's not the transmission mechanism. So that's the point, is that you have to try to see how does this extraordinarily contagious disease, because all of these viral respiratory diseases are extraordinarily contagious. And the reason they are is because they're transmitted by these fine aerosol particles that are in suspension in the air. And in a case like that, will a mask, will something that is preventing spitballs from coming out, protect you or protect others? And the answer is no. It makes no measurable difference. There might be, there are many studies that show how difficult it is to actually infect someone when you're just trying to put something like a fluid or something that is bearing the virus into their eye or into their nose. It's hard to do. That's what the studies show. But if you take a fine aerosol and you breathe it in deeply, that's where the infection starts, and that's where the virus has evolved to be most effective, and that works fine. So breathe in aerosols that are laden with these viruses, you're going to be infected. Try to do anything else, it's going to be difficult.